get the indirect utility, you have to get the prices. Plug them there, that'll become what you see, something like that. That 5 is the outcome of that number and prices together simplified. Okay? Okay. Suppose that is the job you have. It pays you 50,000 or 100,000, depending on your performance. If you don't do very well, you're gonna end up with 50,000. If you do well, they're gonna pay you 100,000. So you have a random income. The probability is equal, just for simplicity. So you have a job paying you 50,000, 100,000, depending on performance. If you don't perform well, you're gonna end up with 50,000. If you perform well, they're gonna give you 100,000. Alright? Okay. What's the expected income if you take that job? You will be this plus this, which is 75,000. Right? The expected value being the average of income, but the weighted average of income. The weight being the probability of each outcome. Alright? So you have taken B11. For high school stat, you know the expected value, right? Make sense? Okay. The expected value is just a weighted average. The weight being the probability of each outcome. Alright? So here, the expected income, if you take the job, is 75,000 bucks. Alright? Okay. For those who have taken B11. If you take this job, do you ever end up with 75,000? You ever get 75,000? You don't. You either get 50 or 100. So how do you say the expected value is 75,000? You never get it, right? The discrete distribution, as they call it, you either get 50 or 100. So how come they say the expected value of that variable in this income, in this case income, is 75,000? What's the meaning of 75,000? Yeah.
Is it 75,000 according to the utility that you would gain?
I haven't brought the utility yet. That's clear. It's the average. I average these two out using a weight being the probability. I call that expected value. So my question is, why they call it expected value? You never get it. You either get 50 or 100. So why we call that expected value when you never get it? Yeah.
Maybe this is the amount that would replace the possibility of him either getting 50,000 or 100,000.
Well, if you put it differently, you never get it. But if you repeat that trial, experiment, that 50 and 100,000 infinite times, you will average 75,000. So when you say expected value, that basically means average. You see? But it's weighted average. But you never actually get 75,000 unless you repeat that experiment over and over. Sometimes you get 50, sometimes you get 100. Over time, you'll average 75,000. Alright? So technically, in the world of stat, the expected value is the center of that distribution. But to get it, you have to repeat the experiment over and over. In every shot, you either get this or that. Make sense? Okay. Anyway, you're going to see it hopefully in B11 if you haven't got it. Okay. What would be the utility satisfaction of 50,000 bucks? Take 50,000, log it in the utility function, report the number. What's the utility of getting 50,000 bucks? Take this one, plug it there, and give me the number. Yeah. What's the utility of getting $50,000? I 50,000 to the power of 0.75. How much do you get? $13,000? 16,700? No, I wrote the 16.7 or not? 718. That's that one. What about 100,000? That's the satisfaction you get from getting 50,000. How much satisfaction you get from 100,000? 28, 100, 17. Okay. The expected utility, the expected satisfaction from that job would be the average of utilities. That is the expected value of your satisfaction. Basically, the average of your satisfaction. How much is that? 20 and how much? 22,000? Probably more. 22? What do you got? What's the expected utility? Expected satisfaction for that job?
416.
How much?
416.
22?
416.
416. So the expected utility is just the average, i.e. weighted average of the utilities. That's what we got there. So if the individual get that job, sometimes he get 16,000 and change Utah, sometimes he get 28,000 and change in Utah. He will average 22 for 16 Utah in satisfaction. Right? That's the expected utility. What if I give the individual 75,000? What's the utility of that one? We call that utility of expected income. What if I give him 75,000, not 50 or 100, just for 75,000? That is what he gets. How much is that? We call that utility of expected income. Get the expected income, plug in the utility, see how much satisfaction he gets from it. How much is that one? What is the utility of expected income? Which is that number? Yeah? 45?
Yeah.
That looks a lot. Are you sure? I think you're making a mistake. You got change? Oh, that's 5, sorry. That's 5. How much you get now? I miswrote it. 22,660. 60. So utility of expected income, that is 22,660, is higher than the expected utility of the same stream of income. That is 22,416. Why that's the case? It's the same individual. If you give him 50,000 and 100,000, which will average 75,000, that is what he gets from it. If you give him 75,000, that's what he gets from it. Why the utility of expected income is higher than expected utility of the same stream of income? Why the two are different? If I give him 75,000, he prefers it over 50 and 100, which is basically averaging out 75. Why he prefers 75,000? If I give it to him, then 50 and 100. Yeah?
Next risk.
Because he doesn't like risk. That's the only difference between the two. He's a risk averse. He's a risk averse, he prefers certainty over uncertainty. If I give him 75,000 certain, it would be better for him than 50 and 100, which is 75,000 just uncertain. Make sense? A risk averse individual, for him, utility of expected income is higher than expected utility of the same stream of income. Because he prefers certainty over uncertainty. Alright? That's this individual. If the individual was risk neutral, then these two would have been the same. He doesn't care, right? 75,000 would have been 75,000 regardless. So if this guy was risk neutral and he's not, then the utility of expected income would have been equal to the expected utility, because he would not have cared. He wants 75,000, risk is immaterial. So for that individual, 75,000 certain would have been the same as 50 and 100, which is 75,000 certain. Alright? If the individual was risk lover, it would have been the other way around. He would have preferred uncertainty over certainty. So he would have preferred 50 and 100 over 75. This individual though is this one. The way I had it, that was the individual we had there. But the relation between these two tells you whether the individual is risk averse, risk lover, or risk neutral. Make sense? Okay. Most people are risk averse. Most people prefer certainty over uncertainty. Alright? Okay. Let's see if you're risk averse or not. This is my offer. 0, $1 million. You wish. I flip a coin, decide. You get 0 and $1 million. You flip a coin, decide. That's one offer. The second one is $500,000. Which one do you take? $500,000 or a chance of getting 0 or $1 million? Which one do you take? Which one? Well, if you don't take $500,000, there's something wrong with you. Most people, the vast majority will take a certain $500,000 than an uncertain one. This is $500,000. You'll average $500,000. That's uncertain though. You prefer certainty over uncertainty. The vast majority of people prefer certainty over uncertainty. They take outcome of the gamble or the gamble. For them, utility of expected income is more than expected utility of the same stable income. Alright? Okay. Let's see how risk averse you are. So you take 500 because you're risk averse. What about 450? You take 450 certain or 0 and $1 million, which is 500 uncertain. Which one do you take? 450? 450. So technically you paid 50,000 in premium to avoid risk. That's what you paid. You paid 50,000 because this is 450, that's $500,000. You paid $500,000, 50,000, because you don't like risk. Make sense? What about if I go to 400? See 400? You're very risk averse. Most people are really risk averse. They prefer certainty. Alright? Most people take certainty over uncertainty. There was a TV program where you pick numbers. You may win $1 million based on how lucky you get, right? And someone was left with 0 and $1 million. If he picked correctly, he get $1 million. If he picked wrong, he get 0. And he was offered how much? He was offered 540. I think definitely more than $500,000. You will take it, right? I'll probably take 350. Anything less, if no one is there, I will take it. I'm not going to take it in front of people because that's sort of embarrassing. It tells you how risk averse you are, right? It tells you you're really scared. But I will take fall. I'm very scared. Someone did not take this one. You know what happened to him? He ended up with this. He lost. Check it out. Check him out. He's on YouTube. I think it's called The World's Biggest Loser, whatever, right? But he was offered 540. Certain. For 500 uncertain. He said no. And he lost. Anyway. The next question becomes, why people become risk averse? Why you're risk averse? Why you prefer 500,000 certain than $500,000 uncertain? What is in your mind? How do you see it? Why do you become risk averse? If you're risk averse, you are concentrating on the lower end. You say, I may end up with 0. That's the way you look at it. That's risk averse. They concentrate on the lower end of distribution. For them, that's worth more. If you're risk lover, you concentrate on the upper end. Say, well, I'll never be a millionaire. That's the only chance I have. So if you look at the upper end, you focus on that part, you're risk lover. If you look at the lower end, you're risk averse. The risk aversion is a function of how you look at money. If you look at money, well, we assume everyone likes money. If you look at the money, and the more of it give you less satisfaction, you're risk averse. We assume everyone lacks money. If you lack money at declining rate, you will be risk averse. If you lack money at declining rate, you will be risk averse. That's the vast majority of people. They lack money, the more they have, incrementally the less they like it. That's most people. That is risk averse. If they lack money at constant rate, then it's immaterial. Money is money. Risk won't matter. That becomes risk neutral. If they lack money at increasing rate, that makes them risk level. Alright, so the reason people become risk averse, risk neutral, risk lower, it depends on how they view money. Most people view money, they like it at declining rate. The more they have, the less satisfaction they get from it. So if you have $100, if someone gives you $50, you're very happy. But if you have $1 million, someone gives you $50, you won't be as happy. That's typical. That makes you risk averse. If you lack money at an increasing rate, which is very rare, you become risk lower. If money is money, it doesn't matter, you're risk neutral. If you check this individual, what was the first derivative? It was this one. That's more than zero. You lack money. What's the second derivative? I missed it there. Minus 125. What's the second derivative? That is risk averse. So the reason you become risk averse because you lack money at decline rate. Since you lack money at decline rate, that makes you risk averse. If that power was more than 1, that was risk lower. The reason it became risk averse is because this power is less than 1. That means the second derivative is negative, right? If the power was 1, the second derivative would have been 0. That would have made him risk neutral. Right? Okay. So let's graph what this individual does. Let's graph the individual numbers. Let me erase this one. We'll do it again in more general fashion. Let's graph this individual utility. That is utility, that's the income. He lacks money at declining rate, the utility should look like this. He lacks money, but at declining rate. Make sense? If the power was 1, this would have been straight. He lacked money at constant rate. If the power was more than 1, it would have been like this. He lacks money at increasing rate then. But this guy lacks money at declining rate. He had 50,000 and 100,000. 50,000 gave him how much? 50,000 gave him 16, 718. Right? That is 50,000. 100,000 gave him how much? So I gave him 28, 117. Make sense? So I'm graphing the numbers. The expected income was 75,000. That was 75,000, which is the expected income. Right? Take the gamble. In the world of stat, anything that's uncertain, we call it gamble. So that's 50 and 100 is just a gamble. So we call it gamble. Connect the dots. I did. Take a line vertically from expected income. What's the name of this bond? Based on our calculations. What do you call that bond?
Utility respected.
Utility expected. That's the expected income. That's the utility of it. Make sense? So this is utility of expected income, because this is the expected income, right? That becomes the satisfaction you get from the expected income, which is equal to how much? 22,660. Make sense? Okay. What is the point connecting? What is this one? And why? What is this one? Anyone? What is that one? I say that point is the expected utility, which is 22,416. Why? Why the line connecting the gamble will give us the expected utility? Why if you connect the gamble? You draw a line from expected income to it, you get the expected utility. That's mathematically always the case. But why? Because expected income, expected utility, they're both linear combinations. Expected income is linear combination of the income. Expected utility is a linear combination of utilities. They should follow a straight line because they're both linear combinations. So that's always the case. If you draw a line connecting the gamble from the expected income to it, that is the expected utility by math. You can't get anything else. Now you can see, as long as you like money at declining rate, the utility expected is higher than expected utility. Right? That's always the case. If you like money at declining rate, this point will be higher than this one. Right? That's mathematically. Conceptually though, why that's the case? Conceptually, if you like money at declining rate, this money is worth more to you than this money. You're not going to concentrate on this one, it's worth less. These dollars aren't worth as much as this dollar. That's what makes you risk averse. You're not going to look at the opera and say, well, I may end up with $1 million. $1 million is not worth as much. 900 to $1 million is not worth as much as the 400 to 500,000. It's worth less. So your concentration will be on the lower end of the distribution, not the upper end. You always think about what if I lose, not what if I win. Makes sense? That makes you risk averse. Right? Make sense? Okay. A risk averse individual become risk averse because they like money at declining rate. And most people like money at declining rates. Okay, let's find another point. Let's find this point. That's a point, a level of income, where the satisfaction is equal to what the gamma gives you. Make sense? This is a point, an income level, that gives you the same satisfaction as expected. So to find it, what was the expected utility? Sorry, I don't need these things anymore. I need the expected utility though. What was the expected utility? It was 22416. That's the expected utility. I need to go to the utility function. Find an income that yields the same satisfaction. As soon as I find it, I'll call it certainty equivalent. I change the name. I call it certainty equivalent. That's a certainty equivalent of the gamble. It yields the same satisfaction as the gamble. As a result, it will be called certainty equivalent of the gamble. So as soon as I put these two equal, I change this to CE. Because that is certainty equivalent of 50,000 and 100,000 yield the same satisfaction as that. Alright? How much is the certainty equivalent here? It should be this one. What do you get? What is the certainty equivalent for this individual? Based on the graph, it will be less than 75,000. Based on the graph, it will be less than 75,000. How much do you get it? If you check the graph, it's less than 75,000. It should be less than 75,000. How much do you get? 73,000?
73,923.
73,900?
23.
23. Okay, that is 73,923. So technically you are inverting the utility function for the expected utility. You're inverting it, you're getting the income from it. That income yields the same satisfaction as expected. You call it certainty equivalent of the gamble as a result. So technically for this individual, 50 and 100, uncertain is equal to this certain. They're the same. They have the same satisfaction. Next step, Mr. Markowitz, we invented modern finance. Mr. Markowitz, call the distance between expected income and certainty equivalent risk premium. So risk premium is basically this distance. For us, it's 75,000 minus 73,923. That's a famous Markowitz risk premium. How much is it here? What is the risk premium for this individual? 75,000 minus certainty equivalent 73,923. It's 1,077. What does that mean? That's the risk premium, Markowitz version. What does that mean? He said risk premium is the maximum you are willing to pay to avoid risk. You're willing to pay as much as this to avoid risk. Anything more, you're not going to do it. Anything less, you'll be more than happy to do it. Think about it this way. The gamble in reality is worth this. That's what the gamble is worth in reality. But for you, it's worth this. You don't like the risk. So you're willing to go to the bank, say, take the gamble. Give me this one. In the process, you give up 1,077 to avoid risk. As a result, that becomes risk premium, the maximum you're willing to give up to avoid risk. Make sense? The more risk averse you are, the bigger risk premium. The lower, certainty equivalent. The more risk averse you become, you are, the lower the gamble is worth to you. The more premium you're willing to pay to avoid risk. So this is a function of who you are. The utility decides it. If you change the individual, that will change. The more risk averse the individual is, the lower certainty equivalent. Make sense? Anyway, Mr. Markowitz wrote an article on this front in 1952, I think. 1952. Can you Google it? I think he was born, we Googled it earlier, I think he was born in 1927. So how old he was when he wrote the article? He was born in 1927, that's 25 years old. So when the article was written, that is when he was 25 years old. If you write an article, it might be like working on a few years, then becoming sort of your dissertation, then publishing it. So he must have written his dissertation when he was like 21 years old, 22 years old. And he invented modern finance. All modern finance is based on the portfolio theory that he invented. And he invented the whole thing from scratch. Think about it, he was 21 years old, he basically invented modern finance. The portfolio theory he invented is that chapter in the book. If you read the chapter in the book, most of it is portfolio theory that is his invention. It's the same way now studied in finance. If you take finance, you can see there. That portfolio theory in finance is actually his work. Still taught the same way. Make sense? Anyway, he was genius. I think he got the Nobel Prize and he lived long enough. He probably passed away a few years back when he was like 100. Anyway, that is what we call Markowitz premium, defined as the maximum you're willing to pay to avoid risk. Does that make sense? Okay, that's the setup. We use two functions. For our case, we either use power function, that is the one I use, that's the power function. Make sense? For a power function to work, we need the first derivative to be more than 0, and first derivative is this one. So we assume A, B, both more than 0. Now the second derivative determines the individual. What's the second derivative there? The second derivative determines the individual. The second derivative will be this one. Is that more than 0? Less than 0 or equal to 0? It depends on what? Depends on which parameter determines the sign of this one? This. The rest are just positive, right? That's B. If B is 1, this is 0, that is a risk neutral individual. He likes math concentrate. If this is less than 1, that becomes less than 0, that is risk averse. The function we use, that was 0.75. That's the reason it was risk averse. If this is more than 1, that makes the individual risk averse. Alright? So the one we had is the second individual, the utility was this way. He lacked magnetic decline rate. If that's 1, you're going to end up with a straight line. He lacked magnetic concentrate. If you have it more than 1, it will become this one. He lacks when you add increasing rate. We concentrate on this one because most people are there. So the reason we put the power less than 1, we wanted the individual to be risk averse. Right? So that function is very versatile. You change B, you change the individual. That is a scalar, doesn't really do anything. It does not change the individual, it just changes the numbers, but does not change risk aversion of the individual. It's all about B. The smaller B, more risk averse the individual is. Make sense? So if you go there in our function, try this on your own. Change this one to 0.25. Redo. That becomes far more risk averse individual. Verify. That makes the individual far more risk averse. Right? You will end up with far lower certainty equivalent, far bigger premium. Right? Try it, you will see it. Very versatile function. You change B, you change individual. If you want to make the individual more risk averse, bring down B. Less risk averse, bring it up. Make sense? So we use it often because it's very versatile. Anyway, that is one. We normally make the power less than 1 just to make the individual risk averse, but we can basically change it from 0 to 1 and change the individual. See, my computer slow. Okay. The second function we use is natural log function. That's a natural log function. What's the first derivative? That's always more than 0. So that individual always likes money. What's the second derivative? What's the second derivative? Anyone? You forgot derivatives. What's the second derivative of natural log? Minus I squared. That's always less than 0. It's always risk averse. Natural log is not a very versatile function. The individual is the same no matter what. It's always risk averse. Alright? This B doesn't do anything. It's just a scalar. Does not change the individual. Unlike power function, where you change B, you change the individual. Make sense? So we use both of them, but more versatile in the literature is power function. This is used often as well, but not very versatile function. It's basically the same individual. Okay. Let's see if we understand the concept. Just a note, I use I often. Sometimes I use W. I is income, W is wealth. We use them interchangeably. So if I go back and forth, it's the same. I prefer income, but sometimes I use W because some books use W. But either one is fine. So this is the individual in this case. I prefer I. Here I wrote W, but let's change it to I. That's the individual. I rewrote this one. That's the power. It's sort of, when I copied and pasted there, it becomes like a multiple, but that's the power. Based on that function and what I just said, who is this individual? Risk averse, risk lover, risk neutral? Risk lover. The power is? He's slightly risk lover. One is risk neutral, more than one risk lover. The higher, more risk lover. The lower, more risk averse. So very, very slow function. This is slightly risk lover, not very slow, but risk lover. So based on that, you can answer this one, that's false. He's a risk lover, not risk neutral. Right? What about D? You should be able to answer it. What about D? Is that correct? He lacks money at? That's the reason he is risk lover. You can see it. The power is more than one. He likes money. That is first derivative. And the second is negative. Sorry, positive. So he likes money at increasing rate. Slightly though, this is so close to zero, right? So he's slightly risk lower, but he's risk lower. You should be able to answer B. His utilitive expected is lower than expected utility. Is that true? Or false? That is true. This is certainty, this is uncertainty. He prefers uncertainty over certainty because he loves risk. Alright? See, that's the certain one, that's the uncertain. For risk averse, it was the other way around. He prefers certainty over uncertainty. This is risk lover. Number one is the one that's questionable. A fair gamble is a gamble with zero expected value. That's the definition of fair gamble. Say, we flip a coin, decide the winner. The winner pays 10, the loser pays 10. Sorry, the winner gets 10, the loser pays 10. So if you're gambling like that, there's 50% chance of getting 10 bucks, 50% chance of losing 10 bucks. That a fair gamble, the expected value is 0. Make sense? This question says he will take a fair gamble. True or false? False?
False.
Why is it false? Yeah.
These are separated.
Okay. Think about it this way. If you don't gamble, you have 0. Certain. If you gamble, you end up with 0. Uncertain. Which one do you prefer? 0 certain or 0 uncertain? If you're risk averse, you prefer 0 uncertain. You're not going to take a fair gamble. If you're risk lover, you prefer 0 certain. You will take a fair gamble. So a risk lover will take a fair gamble. They are replacing 0 certain with 0 uncertain. They prefer the uncertain one. Make sense? Right? Okay. Just to put it differently, this question was actually on the final. It's sort of like this one, but different. This is the utility for someone. That's the utility. Make sense? The question was like this. That's the utility for the individual. The individual has a new car. New car. He spent $140,000 on it. There's 5% chance it's stolen, shipped right out of Canada, right out of Canada. I don't know who wants that car, but that's secondary, right? 50% all lost, all gone. Just think about it. In Canada, 30,000 cars are stolen a year. 30,000. You take a car, you put it in a big container ship, they ship them. How is it possible? Impossible, right? They're doing it themselves. I think they're like, I don't want to say it, but there's internal thing. But how can you ship 30,000 cars overseas? It's a giant car, right? All of them have tags, stuff like that. Anyway, but suppose this one is one of them. If it's stolen, the whole thing is lost. But there's 5% chance of it. Alright? Someone is telling you, pay me 7,000. If it's stolen, I'll give you a new one. Would you do it? Would that individual do it? Yes or no?
What's the question?
The car is worth 140,000. 5% chance is all lost. There's 5% chance. Someone's telling you, pay me 7,000 bucks. If it's lost, I'll give you a new one. Would this individual do it? Yes or no? Why yes? What's the loss here?
5,000. 140.
Why 5,000?
What,
5% of 140, that's 7,000. That's the loss. That's uncertain loss. This is a certain loss. Which one do you take? A certain loss or uncertain loss? Which one do you take? If you agree to it, you're losing 7,000 for certain. If you don't agree to it, you may lose, well, there's 5% chance of losing 140,000, which is technically 7,000 loss, uncertain. Which one do you take? Is risk lover. That's the one thing. The power is more than one. If you're a risk lover, you take the risky side. You take this side. I take my shot. I'm not gonna pay anyone 7,000 because I prefer the uncertain side over the certain side. If the individual is risk averse, it would be the other way around. But he was not. He's a risk lover. And risk lover take the risky side. Everything equal. Make sense? He's a risk lover. He takes uncertain 7,000 loss over certain 7,000 loss. Right? Simply because he was risk lover. So no calculation was required. Just saying as a risk lover, he loved the risk, would have been good. Alright? Makes sense? But some people calculated the numbers and got the outcome right that way. It's fine, but it would take more time. How it's calculated, that's the next step. But some people actually did some calculations. Make sense? Anyway. Okay, I want to find your premium. 0 and 1,000,000. Alright? That is equal probability. How much you take for it in certain? What's the minimum you take for it? If someone offers you money for certain, what's the minimum you take for it? 400, 300, how much do you take? What's the minimum you take for certain, for 500,000 uncertain? You say, what's the minimum you take? You already went to 400,000, so see how far you go. What's the minimum you take?
Maximum of 200,000. Below
You go to 200?
below that, I will really pick up.
So that is certainty equivalent for you of that gamble. Make sense? So the premium you pay is 300,000. Your risk premium is 300,000. That's what you do. You're giving up 500,000 for 200,000. In the process, you're going to give up 300,000 because you don't like risk. You're very risk averse. Right? You're very risk averse. Most people are risk averse. Most people are risk averse. Not so. That's very risk averse. That's really extremely risk averse. But most people are risk averse. If that's the case, then why do you buy a lottery? If you buy a lottery, you pay $5. The expected payoff is like $3. That's a lot. Right? The law says the gambling institution should return 60% of what put there. So if you go to casino, whatever put there, 60 cents return. Every dollar, 60 cents return. That's completely unfair gamble. Why do you do it? Why put $5 certain, getting $3 uncertain? Why people gamble? Why people actually buy lotteries if they're so risk averse? That's how risk averse you are there, right? Very risk averse. Then why do you buy a lottery? You buy a lottery? I know. A lot of people buy a lottery. If people are risk averse, and the vast majority are, why they buy the lottery then? They are paying a premium to take the risk there. They pay $5 certain, they get $3 uncertain. They're paying $2 in premium to take the gamble. What would they do it? Are they that risk lovers? They're not. It's just a paradox. People, when it comes to small money invested, big money, even with a tiny probability, they lose their mind. Right? So technically buying lottery is dumb in economic terms, because nobody is that risk lover. It's completely irrational, right? Well, if you want to put it nicely, it's irrational. If you want to put it not nicely, it's actually dumb, right? But a lot of people do it because they lose perspective. They always say, if you don't play, you don't win. And they always keep saying, if you play, you still don't win. You just lost your money, right? The chance of you winning a lottery is equal to the chance of you winning a lottery and getting out and being hit by lightning. Twice, not once. That's how unlikely it is. You're not going to win the lottery, right? It's just technically impossible. But people, well, I know a prof for a long, long time who was telling me he buys lottery 2 times a week because he's hoping to win a lottery and quit his job. He has not quit his job yet. What's the likelihood? It's 0, right? It's just a waste of money. But people do it because they become completely irrational. It's a product, right? Because there's research done there trying to quantify people risk aversion. And not everyone almost risk averse. No one is so risk lover to take a gamble that fetches you paying $2, 40% premium. Nobody does it, right? But when it comes to small losses, big, improbable gains, people lose their mind. Yep, go ahead. This one?
To the left.
Risk premium. Risk, the pie is the way we write the premium.
Pie.
Risk premium. Anyway, let's do numerical questions. Don't buy a lottery. That's not very smart. And I've never bought a lottery in my life. It's just dumb, right? It's completely dumb. I'm very rational. It's dumb. It gives you a false hope. It actually makes you lazy, right? It basically drives you there every week to buy it, and they say, well, I may win a lottery. You're not going to win a lottery, right? And people actually become lazy, right? Just have the opposite effect. It's just not a very smart idea. Anyway, that is the utility. See, I mixed up here between income and, well, I should use the same. That's 10 income on 5. That's the power function. The power is less than 1. That's the risk averse individual. Make sense? So if you want to graph the utility, should look like this. That's the utility. You like money at declining rate. So as soon as I look at the power less than 1, that's the graph. Alright? So be careful. Graph what you see there. Say on this question, when I put 3 there, some people actually numerically solved it. But still when they graphed it this way. That's not this individual. The power is more than 1. It should be this way. The graph was wrong, but somehow the number is right. Make sense? So check what the question is. Graph it. I marked the finals myself, so I see weird stuff. I did not deduct mark there, because the question didn't ask you to do it, but check the question, don't be generic. Solve that question, right? If it's risk lover, the slope goes up. If it's risk averse, it goes up. Anyway, this individual has a house worth $500,000. And can be burned down to $300,000. The probability is 1 over 12, so this should be 11 over 12. Make sense? What's the expected value or expected income for this individual? It should be 1 over 12 multiplied by 300,000 plus 1112 multiplied by 500,000. What do you get? 400? Do I remember it? 8, lots of 3's. Is that right? So for this individual, this is stream of income, or this is the gamble. See, this graph is not up to scale because I want to open it up. We need the utility of those two incomes now. So I need the utility of those two incomes. I need help there. Take the, let me write it here so we can see it. Take the income, plug it in the utility function. What do you got? Take 300,000, plug it there. What's the utility of 300,000? 5,000? 4? 77? Okay, that's that. What is the utility of 500,000? Plug 500,000 there. What do you get there? 7,000? 71. That's fine. 477. That's 7071. Right? Find the expected utility, which is 1 over 12 multiplied by 5477 plus 1112 multiplied by 771. How much that would be? That's the expected utility. How much is that? What's the expected utility? 6,000? 900? I want to move the rest. How much? 52? 38? 38, 52? 38. That's the expected utility. Find utility of expected income, which is utility of getting 483333. That should be 10 483333 to the power of half. How much is that? That must be higher than the expected utility because the individual is risk averse. What do you get there? That's the utility of expected income. How much is it? What is the utility of expected income? Must be more than 6938. Because the individual does not like risk, he prefers certainty over uncertainty. 6952?
Yes.
6952. So now we can graph it. Connect the gamble. I did connect the gamble. Write down expected income. That's the expected income. Run a line vertically up, which I did. What was the name of this bond? What did you call this bond? That is utility of expected income. All right? That's the expected income. That's the expected income, and that's the utility of it, which is 6952. All right, that's 6952. What did we call this bond? That was expected utility, which was 6938. Right? Make sense? Okay. Now the last step we have to calculate to fill up the graph is this point. What did we call that point? What was the name of this point? Anyone remembers? The name of it was? Certainty equivalent. That's a certainty equivalent of the gamble. That yield the same satisfaction as the gamble. Alright? So to find certainty equivalent, which we needed here, take the expected utility, which is 6938, go to the utility function and invert it to find C. Find an income. In the utility function, yielding the same satisfaction as expected. That will be called certainty equivalent. So in this case, certainty equivalent is how much? It's 6938 divided by 10 and squared. How much is that? That yields the same satisfaction as 300, 500. That's a certainty equivalent to the gamble. How much do you get? 4, 8, 4, 7, how much? 4? I think there's an 8 there. 4, 8? How much? 4, 8? 1, 3? 1? 5. So that is 4, 8? 1, 3, 5. We call this
5, 8.
4, 8, 1, 3, 8?
4, 8, 1, 3, 5, 8.
No, just round it. It's fine, round it. But the number is so big, rounding is not an issue at all, right? Rounding will be an issue, the question will say. You will see in a bit. When the rounding is an issue, the question will say. Yeah?
No, it's 481358. That's like without rounding.
Oh, I see. Okay. Why are you so mad? It's like 4 o'clock in the afternoon. I didn't have lunch even. What do you expect, right? Anyway, 4, 8, 1, 3, 5, 8. I missed it by just a bit. Just 400,000, I guess. 4, 8, 1, 3, 5, 8. Right? Make sense? Okay. We called expected income minus certainty equivalent, we called it Markowitz risk premium. That's the risk premium as defined by Markowitz. So in this case, Markowitz risk premium is 483333 minus 481358. How much is that? That's the Markowitz risk premium. How much is it? $19? Okay. Can someone explain in words what does it mean? Okay. What does that mean in words? That's the Markowitz risk premium, right? What does it mean in words? Yeah.
It means that he's ready to pay that much to avoid the risk.
Okay. Tell us which risk.
By taking the risk.
The meaning is this: the gamble is worth this. So that's what the gamble actually worth in reality. The outcome of that process is this one, right? For you it's worth this. So you're willing to pay this. Right? If someone offers you this. If someone offers you 483,333 for something that's worth this, you're willing to pay the difference. That's the meaning of it. That's one way of putting it. Or you can say, I'm willing to give my home, get this for it. In the process, you give up this. Make sense? Okay. You buy a full insurance though. What do you get post full insurance? Suppose suppose you go there, buy full insurance. What do you get from the insurance company?
The full price of the house.
So this is not full insurance premium. This is market's premium. Basically assumes if someone gives you this for something that's worth this, you're willing to pay the difference. But if you buy full insurance, you will end up with $500,000. That's not full insurance premium. Make sense? The question says, how much you're willing to pay to fully insure yourself? That's a risk premium, but not market's version. Alright, that is full insurance premium, which is what you get post full insurance minus how much that is worth to you. So don't mix them up. They're both premiums. Market assumes you get the expected income for something that's worth less. You're willing to pay the difference. Make sense? The full insurance premium is different because if you buy full insurance, you're gonna end up with $500,000, not $483,033. Does that make sense? What is a full insurance premium in this case? What's the full insurance premium in this case? 6? 42. In the literature, they don't differentiate. In the literature, they say that's risk premium. You have to figure out which one it is. I just differentiate it just to help you test what. In the literature, they don't tell you which one they're referring to. Is it full insurance risk premium? You have to figure it out from the question, right? But I differentiated, give them different names. But in the literature, we don't have Markowitz, risk premium, full insurance risk premium. We just have risk premium. But depending on the case, the numbers are different, right? Markowitz risk premium is assuming you get the expected income for something that's worth less to you. So you're willing to pay the difference. Full insurance, you're going to end up with $500,000, not 40. Graphically speaking, this is full insurance risk premium. Make sense? That is Markowitz risk premium. Premium is how much you get in certainty versus how much uncertainty is worth to you. Depending on the case, the premium will be different. Like differentiated, but Markowitz did not differentiate. He just called it premium. By his definition, that was the premium. By his definition, you are getting this compared to what it was worth to you, which is certainty equivalent. So make sure you differentiate there. Anyway, okay, that is part B of this question, which is how much you're willing to pay to fully insure yourself. That's a risk premium, but not Markowitz version. That is full insurance premium. Let me add another part to it. C. Suppose you're offered 60% coverage, not full insurance. Full insurance is 100% coverage. You're offered 60% coverage for $10,000 in premium. That's the partial insurance which gives you 60% coverage. Would you do it? Would you buy a 60% coverage for $10,000 premium? Make sense? I could have made it more complex. Could have said, what's the maximum you're willing to pay for 60% coverage? That would have been much harder, but I simplified it. I gave it the premium, I gave it the coverage, tell me whether you take it or not, and why. Partial insurance, if you want to use risk premium approach, that becomes more complex and more time consuming. Just calculate the expected utility if you buy the insurance. Compare it with the expected utility of not buying it, which you already have it. So this is what you do. You already have expected utility of no insurance. That was how much? 6938. But it's given, you already found it. Try to find expected utility if you buy that coverage. And the better is the higher. Right? Make sense? So assume you buy the insurance, see how much satisfaction you get from it. Okay? Okay. Now, this is your stream of income. The probability is the same. That's not going to change. Right? But if you have insurance, then there is coverage. The coverage arrives when you lose money. Not there. So the insurance company pays you nothing when there is no loss. Right? Make sense? If there is fire, losses, then there will be payment. How much is the payment? You're gonna get a check from an insurance company. When there's a fire, your house is worth less now. How big the check is based on the coverage rate. How much that would be? You're gonna get money, right? You're insured, you're gonna get money. Based on the 60% coverage, how much do you get? 180. Why? It is 60% of the loss, not what you end up with. Well, you add it backward. One more time. Is it 180? How much do you lose? So why did you say 180? 120, right? 120. It's 60% of the loss, not what you end up with. It's 60% of the difference between these two. That is 120,000. When you get a partial coverage, it partially covers the loss, not what you end up with. That's the way it goes. Say if you buy drug insurance, which has 90% coverage, you pay 90% of the cost, the rest is paid by the insurance. Sorry, the other way around. 90% is paid by the insurance, 10% is paid by you. Make sense? So in this case, you lost 200,000. 60% is covered. That's 120,000. Then you have to pay the premium. When do you pay the premium? When do you pay the premium? You have to pay $10,000. When do you pay it? Always. That is like buying car insurance, you pay the premium, and then if there's an accident, they're gonna fix your car. Sometimes they fix your car completely, that's the full coverage. Sometimes there's deductible, that's technically partial coverage. Right? Okay. So if you buy the insurance, you're gonna end up with 490,000 there. How much there? How much do you end up there? 410,000. Right? What's the utility of that? The utility of that would be 1 over 12, 10, 410 to the power of 1 over 2, plus 11 over 12, 10, 490 to the power of half. That's the expected utility of buying partial insurance. Alright? Okay. Report these two numbers. I need them later. What is this one? What is this one? Then report the whole thing. I need these two numbers. Report them, then average them out. What's the first one? What's the utility of 410,000? This one. What is this number? I need both because we need them for the next part of this question. What's the first one? What's the first one? 6,000, 5,000, how much is it? I need this, then I need this, then I need the whole thing. But I need them individually for the next part of this question. How much you get? 600? It was in thousands. How did it become 100? I thought the whole thing is in thousands. Like this? What's the next one? What's that one? I think you did not multiply by 10 probably. What's the next one? Exactly? Okay. So what's the whole thing? What's the expected utility if you buy the insurance, which is the average of these two? What do you get there?
6,950.
Average amount. Give me the number.
6,950.
6,950.
950.
That's better. That's a good policy. You'll do it. Will make you happier. You shouldn't do you shouldn't do premium to partial insurance because the outcome is uncertain. Cannot be compared with certainty equivalent. If you want to compare it with certainty equivalent, you have to take this, calculate certainty equivalent of this one. That's an extra step. Why do you want to do it? Make sense? So it's a waste of time. If you have partial insurance, that's the easiest way to do it. If you have full insurance, use risk premium. Alright? Okay. Question for you. With 1/12 probability of loss, that was a good policy. Right? Make sense? If the probability of loss goes up, will that make this policy better or worse? Will it be more likely to accept it or less?
More.
With more. The more chance of loss, the more chance you buy the insurance. Alright? If this comes down though, at some point you may say, well, that's not a good policy. Alright? At some point you say, what's the chance of losing, right? I'm not going to insure. Alright? So, part D. Part D. Find probability of loss. Call it P. That makes you indifferent. Between buying 60% coverage or not. Let's see if we can find it. With 1/12, you will buy it. If probability is lower, at some point you may say, that's it, found that point. Alright? Find a break-even point which makes you different between buying the insurance and not buying it. I'll try it, I'll start it, we'll take a break, we'll do it after. This is the way you do it. That's the probability of loss. This is no insurance. You're gonna end up with this one then. This is probability of no loss. Then you're gonna end up with this utility. That is expected utility, which is a function of probability of loss if you don't buy the insurance. We already have these 2 points. Give me those 2 points. I don't want to go back. What's the first one? 600? 6,000? I know this was 7,000. How much was it? What was the first one? That's the one on the graph.
6,403.
403. Are you sure?
Oh.
No, not this one.
Oh.
That is this one. That's before the insurance. That's no insurance. 5,477. And the other one is 7,077. 71. Alright? 5477. This is 54. And this is 771. That's before the insurance. Now if you buy the insurance, then that is the probability, that is what you end up with. And that is the probability, that is what you end up with. And those are the 2 numbers that we wrote up there. This is 6,403. This is 7,000. Right? If you put these 2 equal and solve for the probability, that is a break-even point. That's where you are indifferent between buying the insurance and not buying it. Make sense? That's a sort of a in-between case. So to solve it, I'm going to arrange the probability on one side, 1 minus probability on the other side. Alright? the probability going to one side will become this minus this. How much is that? This minus this. How much do you get? This minus this. Help me out with it. This minus this. What do you get?
926.
900?
26.
24?
6.
26. That's this end. At the other end, it will be this minus this, which is 71. That's the easy one. So now you can easily solve for the probability. It would be 71. 71 plus 926. That's the break-even point. Any more, you'll buy the insurance. Any less, you're not going to buy it. How much is that? Small number, because with 1 over 12 you did it. It must be smaller than 1 over 12. So this is small number. How much do you get? Whatever you get multiplied by 100, report in percentage. What do you get? 7%? 7%. What was 1 over 12? In percentage, how much is that? I know it's lower, but I want to get 8%? It was close. We know it's lower. We know it's lower. It was 8%, a bit lower there. If it's right below this one, the policy is not worth buying. The risk is too low, you're not going to buy the insurance. Make sense? Anyway, that is this. I will take a break. I'll do a similar to it, but from the lecture number 5, we stay within the framework of those questions. We don't extend it because the book, 95% of it is actual portfolio theory, which we don't want to do. Anyway, short break.